The Great Lunar Expedition for Everyone gives 213 teams the opportunity to design a space science mission to be carried out from the surface of the moon. This small 2 by 2 inch PCB contains all the components necessary to record thermometer, accelerometer, and magnetometer data, relaying it all back to Earth through a lunar lander and satellite relay system. The Lunasat is programmed just like an Arduino and contains components readily available as Arduino compatible breakout boards from various consumer vendors. The difficulty of this project comes both from the harshness of the lunar environment as well as from the limited capabilities of the Lunasat itself. At the moon's equator, days and nights last for approximately 14 Earth days. During the day, temperatures can reach 120 degrees Celsius and then plunge to negative 130 degrees Celsius at night. It is not currently known at what location the mission will land, but if the mission were to land at either pole, the conditions would be even worse. As latitude increases, the maximum height of the sun in the sky throughout the lunar day decreases. This results in more consistently cold temperatures, but also makes it more difficult for the solar panels to produce power. This will limit the operational time of the Lunasat to just a few Earth days or even hours. It is estimated that due to the extreme temperatures and radiation, the Lunasat will only function for a maximum of 2 lunar days. The Lunasat is based on the Atmega 328 microcontroller, with 32 kilobytes of storage for the static flight software and just 2 kilobytes of SRAM, where all the collected data is stored before being transmitted or discarded. The mission that we have designed for our Lunasat looks to collect accelerometer data from seismic activity as well as asteroid impacts, while at the same time analyzing the effects of the lunar environment on the Lunasat's electronics. The software we are developing to run the Lunasat implements a finite state machine designed to limit software size and complexity while also accomplishing the mission goals. Accelerometer data is constantly collected, but only once the magnitude of the acceleration surpasses 2 standard deviations above the rolling average does it begin to transmit the data. Diagnostic data and readings from the thermometers and gyroscope are to be sent at periodic intervals. Once the data is collected and relayed back to the ground station, the analysis work will have just begun. We intend to perform statistical analysis on the data, as well as characterizing drifts, transients, and other patterns to help us better understand seismic activity and impacts on the moon, as well as the effects of the lunar environment on satellite electronics.